Hi, my name is Dylan, and I'm going to be walking you through a tutorial to show you the difference between rear-wheel drive and front-wheel drive. And first we're going to have to build a cool little rubber band car like this.
To start off, you will need 2 large ice pop sticks, 1 small ice pop stick, 1 plastic straw, 2 wooden rod of 8 inch, 1 rod of 1 inch, 1 rod of ½ inch, 4 plastic bottle caps, some type of adhesive, and a rubber band. First, measure and cut the ice pop stick depending on the desired width of your car. Then, use your adhesive to fix the smaller stick to 2 larger sticks. Next, at the end of the ice pop sticks, attach or glue the 2 smaller pieces of straw to each of the ice pop stick. After this, glue the larger piece of straw so it crosses both ice pop sticks. Now we will attach the wheels. Push the water bottle cap on the end of each rod. Use our adhesive to make sure the wheels stay in place. We are almost done. Next, glue the 1 inch rod to the middle of the smaller ice pop stick and glue the ½ inch rod piece to the middle of the rear axle. Finally, hook the rubber band to the front rod piece and stretch it back to hook onto the rear axle. And we're done.
So now that we have our car built, we're going to go over kind of the main difference between front-wheel drive and rear-wheel drive. So when you think about a front-wheel drive car, most of the time you're going to have your engine in the front. And so the weight of that engine is pushing down on that drive axle in the front, giving more force down so the friction on the tire grabs better. So we're going to simulate this by taping 2 bolts to the front right over your drive axle. And that's the one that you super glued this little guy onto. So after you do that, you're just going to want to wind your car up, and you will see that it's not squirrely at all. It'll go straight, and that's because it has that weight bearing down on the drive axle. Like so. You can see it went pretty straight. It didn't move, the wheels didn't spin in place. However, now we're going to simulate a rear-wheel drive car. And in this case, it's the opposite. So the engine is not over the drive shaft, and it's over the stationary shaft. And so there's not as much downforce over that drive shaft to generate enough friction for wheel spin. So we're going to do something very similar. You're just going to want to tape those 2 bolts on the opposite end of your car from last time. And then you want to wind up your car one more time. And you'll see this time it's going to be a little more squirrely because you don't have that weight on the back. In some cases, your car might not even move. You see, it barely even went forward. It kind of just skidded forward. And if you notice, the wheels, they spin in place for a majority of it. And it's because you don't have that weight bearing down from your bolts. So now I'm going to challenge you to use any kind of weight configuration you think that will make the best car. Challenge your friends, challenge your siblings, or even your parents, and see who can make the best car. And now, I'm going to pass it on over to the racetrack, and they can explain how this phenomenon works in actual cars.
Hi, my name is Yehya, and I'm here with my good friend Somesh at Thunderhill Raceway in sunny California. Have you ever seen cars sliding in movies? Have you ever wondered how they do that? Why don't you see cars slide in the neighborhood? To answer that question, we have to talk about friction. Friction is everywhere around us. When you go running outside, the rubber sole on your shoe prevents you from sliding. However, if you were to step on a banana peel, you would slip because the friction between the banana peel and the ground are low. Like our rubber shoes, we have our cars with tires, both at the front and the back. These tires help the car to steer itself and control itself against the ground. It is because of friction between the tires and the ground. Today, we're gonna have a water truck which is gonna spray water on the track so that the car loses friction with the tires and the ground. Behind us we have 2 cars that may look similar but behave differently when sliding. The 2 main ways of sliding are understeering and oversteering. We are going to introduce our 2 drivers now, Ryan and Bill.
Hi, my name is Bill. and I'm the owner of this 2016 Ford Fiesta ST.
Hi, my name is Ryan, and I'll be the driver of the white Scion FRS today.
Under the normal circumstance, all four tires of a car should have a negligible amount of slippage between them and the road surface, and driver is in control of the vehicle. But sometimes, conditions are less than ideal. What happens when there is rain or snow on the road? The friction between the tires and the road surface is significantly reduced, and tires start to lose traction and slide. When the rear tires on a car lose traction before the front tires do, the car will get into a state known as oversteer. Oversteer is the tendency of a vehicle to turn more sharply than intended, which is demonstrated here. Here you can see the rear end of the car sliding more than the front, creating this cool drift that Ryan's pulling off. Well, that is until he spun out. To put it simply, oversteer happens when a car's rear tires lose traction and start sliding before the front tires do while cornering. It can be fun for an experienced driver to intentionally cause a car to oversteer, but for an average driver, oversteer is dangerous and difficult to manage.
On the other hand, understeering can be more controllable.
Understeering is when the front tires slide more than the rear tires. Therefore, the name understeer, because when you turn the wheel, the car does not steer anymore, even though you're giving it more steering angles.
As you can see here, the driver of this little orange car is having difficulty turning around a circle as the car pushes wider and wider. The front tires have exceeded their adhesion limit and are now starting to slide, causing the car not able to turn enough even as the driver turned the wheel more. This is called understeer. And trust me, it is a pretty dreaded feeling when you turn the wheel and the car simply refuses to turn.
So much understeer. This is unreal.
Now that you're familiar with the two different types of sliding, oversteering and understeering when the car loses friction, of course, let's see why this is important.
When engineers design a car, they can design it to be understeering or oversteering at the limit. Most of the time, engineers would design a car to be understeering, as that is the easier of the two to handle, especially for lesser experienced drivers.
That was a lot of fun, wasn't it? There's a lot more that goes into how cars slide when the tires lose friction with the ground. What we've just shown you is just the tip of the iceberg. A lot of you must be thinking, how do I learn more about cars? How do they go around a turn? To answer these questions, you can do a lot of things. For starters, in middle school and high school, take more science classes, more engineering classes, math classes. When you go to college, join clubs, organizations, like the Society of Automotive Engineers, SAE for short. With the STEM career, you can choose many paths, such as mechanical engineering, computer science, and software engineering, and many others, all of which contribute to the development of a modern vehicle.
We thoroughly enjoyed making this video, and we hope you enjoyed it as well and learned something about cars. Remember, cars are fun, and engineering is fun.